So just to answer that question then, so looking at those, if we need to answer where are points of inflection, you would now answer it as, well, I've got x equals q, x equals r, x equals t, and what basically one way of doing it is saying f dash dash of point q is 0, yeah? F dash dash of point r is 0, f dash. That is so let me, so this is what's accepted. It says find the values of x. So I think at this stage we're kind of x values. So x equals q x. Yeah, I think we're just to be safe, we should definitely write x equals. We might get away with q, r, and t, but let's have a look. What does it say? Special find values. You might get away with it. Are you happy with the reasoning which to get the mark? So we've got options such as has turning points, if you like, but we need to know, and therefore the second differential is 0 is another way of saying it. So whichever one works for you in that. Award nothing if incorrect answers are given. And that's, do you understand why that? Because if you give me a correct answer but followed by a right answer, it might have been a lucky guess. So we kind of just go, no, it's all or nothing. So you're almost better off if you're not sure, just give like 2 correct, then you'll get something, potentially. Yeah. All right, back to this. This question, by the way, the next one here, we can put this one on hold. So the area enclosed by the graph, that's going to be integration. All right, so we can sort of put a can't do it yet. Put a star on it. Yeah, that's exactly what I did actually. Right, so a bit of algebra, wonderful logarithms and things like that. So this is this can be good. We've kind of briefly talked about it. Let's start actually using it now. So we've got y equals the natural logarithm of x divided by x to the power of 4, and we've got to show that dy dx is equal to that. Okay, so basically we ignore the answer they've given and just say, well, we've got to work out what dy dx is. Yeah. Okay, so looking at that, how would you go about doing it? There's 2 possible options, I would say. It's not chain rule because those 2 functions are not embedded, but it is quotient rule is an option, yeah, because they are a quotient. The other option is, like we know when we first did product rule, and I was giving you division, you just move. So I could change this to x to the power of -4 times. So the options are do quotient rule with that, or if I change this to x to the power of -4 times the natural logarithm of x, then I could use product rule. And I think we kind of went through and said either or will work, but up to you. So should we do quotient rule? Do you remember quotient rule? Well, you don't need to remember it, but it's in your formula booklet. But if you can't remember it, it's v, so u divided by v, it's v du dx minus u dv dx, all divided by v squared. So my advice, identify u, u is the natural logarithm of x. Du dx, do you remember? Yeah, what is it? It's one to remember. 1 over x. Yeah? V, we've got x to the power of 4. So dv dx is... Yeah. Then we just need to put all that into question. So x power 3 minus, I'm going to write 4 x cubed natural log of x. All of that is divided by x to the power of 8. Good. Okay. We're getting close to what they wanted, but not quite yet. So what can we do now? So all right, so you're saying you're cancelling the x power 3. Yeah. Okay, we've got it in both, so that's fine as long as that's what you were intending. Because if you just did it on that one, you were going to leave it there. That's not correct. So technically, what we could do is, as long as we cancel with both, because what we would do is actually factorise x to the power 3 1 minus 4 natural log of x over x to the power of 8, which then we can cancel, which does give me 1 minus 4 natural log of x divided by x to the power of 5, which is exactly what we wanted. Okay. So hopefully that's what you were going to do, because if you'd have just done it with 1, you'd left x to the power of 3 in there, you would never have obviously been able to do it. So be careful when... Yeah, and that's just basics with division, isn't it? Like, if there's an addition or a subtraction between terms, you can only cancel from both, because what we're doing is we're cancelling common factors. We're not cancelling individual terms, okay? All right, but we've got that. Consider the function natural log of x divided by x to the power of 4, which is what we just started with. The graph of f has a horizontal tangent at point P. So that's a fancy way of telling you something without telling you something. So what am I supposed to take from the words horizontal tangent? No. Not necessarily. What equals 0? Gradient equals 0. Okay, so we know that dy dx equals 0. That's the important thing. A horizontal tangent means got a straight line, and like a graph does that, right? Or from above, whatever. So that's what we're doing. So when we're doing these calculus type questions, there's only certain things, like we have to be able to differentiate lots of different functions, but when it comes down to it, well, the gradient's positive, negative, or 0. That's what we're looking for. Yeah? So we're always looking for other ways that they're saying that kind of information. So what do we do with that information? Well, we've got a function for gradient, no? Yeah. What was that? So that's the 1 minus 4 natural logarithm of x over x to the power of 5 equals 0. So now you know why part A was a show that question. Because if you can't do that, you can still do this, as long as you remember to put it to 0. Yeah. So if you'd have messed up part A with the potential mistake you were going to make, and you couldn't get there, doesn't mean you're stuck. You can still carry on. You can say, well, that equals 0. Now the test, can we solve for x? Okay, point P, so we're trying to find x at point P. So, how can we go about doing it? Any ideas? Looks trickier than it is. Not yet. You can't do 1 minus 4, no, that's definitely not allowed. Because it's 4 natural logarithms of x, it's not a 4. Yeah? It's not 1 natural logarithm of x minus 4, it's just 1 minus 4 natural. So we can't just do that. Just in the same way that we can't do 2 minus 4x. 2 minus 4 doesn't give you how many x's you are. So yeah, we can. And what would that give you? So if I times by x to the power of 5, I get... Yeah, good. There is another logical way to think of it, which is if you've got a division and the answer is 0, what must be true? I'm thinking more like if something divided by anything is 0, the something must be 0. Because the only way to get 0 is to do 0 divided by something else, yeah? So that there's another logical way to think about it, like you just said. All right, so now we're in a much easier phase. What do we do now? No, not at all. Think of this as, if you like, 1 minus 4x equals 0. Because the natural logarithm of x is just a number. Right? So what would you do if it was like this? Add 1, that would give me 2 here, and 1 over here. We could minus 1, that would give me minus, but I'm not going to do that, just because it's a bit messy. Long right, I'm going to add this lot, yeah? Minus 4 natural logarithms. Why? Because if I add 4 natural logarithms of x on both sides, I do what you were about to do, but I end up with positives instead of negatives. Okay? So although yours would have been fine, you'd end up with -1 and you could have just then ignored the negative. It's kind of like, well, let's just do it a more efficient manner first. Okay. So what would you do if it was 1 equals 4x? Divide by 4. So we divide both sides by 4. We get 1/4 equals the natural logarithm of x. Okay. Now we can use our understandings of logarithms and convert this into an x equals. Do you know how to rewrite your logarithm stuff? Well, this is in logarithmic form. I want it in exponential form. So you've got to think, what does the logarithmic statement tell me? Well, we need... Close. X equals e to the power of 1/4. Yeah? Yeah?
Yeah.
Because I don't, like, maybe you were thinking if we had log to the base 10 of x equals a quarter, that would have been x equals whatever base that is, which is 10 to the power of whatever that, 10 to the power of a quarter. So whatever we chose to do that, that's what the base becomes. So we had natural logarithm, which means that you got the e bit. So it's just making sure that you can rewrite. So we've got x is e to the power of a quarter.
Yeah.
So that's where point P is. It says find the coordinates of P. Yeah, so we've got x coordinate. How do we find the y coordinate? Nope. So if x equals e to the power of a quarter, we are now trying to find out what the y coordinate is. Do we have any way of finding a y coordinate? Exactly. We go, this is quite often what happens. We go back to the initial function. That's how I work out the y coordinate. So we are going to do f of e to the power of a quarter. Okay, so we know f of e to the power of a quarter, okay, is, well, what was the, so we've got the natural logarithm of e to the power of a quarter divided by e to the power of a quarter to the power of 4. Okay, that's because we had y equals natural x over, just in case anyone watching the video doesn't know why I've written that. So now we've got to deal with that. Good. Yeah. It's what? Yeah. So it's 1. Yeah, you're right with that. The natural logarithm of e is, if we said that was x, then we would be saying that e to the power of x equals e, so therefore x must be 1. Yeah?
Right.
But we've not quite got that yet, so how do I rewrite? Hey? So how do I get to that? What's my law of logarithm state? Well, it states that, good, yeah, quarter natural logarithm of e, okay, which then becomes 1/4 times 1 over e, which, how do I write properly? 1 over 4e. So my coordinates are e to the power of a quarter, 1 over 4e. So what looks quite tricky, and you know, with all the e's and natural logarithm stuff, is actually relatively easy if you know your laws of logarithms, if you know that kind of stuff. Given that the second derivative is 20 natural logarithm of x minus 9 over x to the power of 6, show that P is a local maximum point.
Wait,
No, so if P is 0, no, sorry, if P is a maximum, right, what we're saying is it's like this, right? If it's a local maximum, so we're saying point P, and point P is at e to the power of a quarter, 1 over 4e, yeah? And we're saying that that is a maximum. So what we have already stated is that f dash of x equals 0. Okay? Now, what we then know is to the left of it that f dash of x must equal a positive, and f dash of x to the right of it must be a negative value. All right, so we could do it that way, but we are being asked to use the second derivative. Well, think about what we just did before. Okay. So turning points are when f dash of x is 0. Okay. We want to know whether the gradient goes from positive to negative. But, you know, so how could we... So what would the gradient graph look like? If this was the initial graph, the local bit, the gradient graph would be like this, yeah? So if that's f of x, this would be f dash of x. F dash dash of x would be a straight line, but it would be in the negative region, the gradient of the gradient. Okay, so for this to be, so here's the axis for this one. So gradient must be positive, positive, positive until point P. Then it must be negative. At P, the gradient must be 0. What does that mean? Well, if that's going to be like that, approximately, roughly, then the gradient of the gradient is going to be a constant, but it's going to be always negative. So we can then say that f dash dash of e to the power of a quarter must be negative, right?
Yeah.
So we just need to show that. So on the mark scheme, that's what we're saying. We've realised that the second derivative must be negative, yeah, for it to be a maximum. Chuck it in, work it out. Again, it's a non-calculator paper, therefore you've got to be able to do this without a calculator. Which we would do, but it's recess.